Section 2.4a will be about solving quadratic equation. For the first part, we're going to keep the focus on solving quadratic equations by factoring. Now, we need to remind you that some, but not all, quadratic equations can be solved by factoring a quadratic expression followed by using the zero product principle. Now, two things that we're going to talk about. We're going to talk about identifying when a quadratic equation is in standard form, which is required to start solving your equation, and then how to use what is the zero product principle and how to use it to solve a quadratic equation. Now, a quadratic expression is an expression that the term with the highest exponent has an exponent too. So the highest exponent of this expression is 2. Like this one, this expression ax squared plus bx plus c. So that's the general format of any quadratic expression with a not 0, because you will lose the square if a equals 0. You don't want to lose the square. So that's why we set the condition for a not to be 0. And now it's in standard form when you have the expression entirely on one side of the equation, just like this one. And on the other side, you have 0. Sometimes you may want to do it. You may have to do it to get your standard form. But standard form is when you have the quadratic expression on one side of the equation and then 0 on the other side. For example, if you have 2x squared minus x plus 5 equals 0, this is a quadratic equation in standard form. And if you don't have the equal 0, you only have a quadratic expression. So what is the zero product principle? The zero product principle is a principle that says if the product of two factors is equal to 0, then at least one of the factors must be 0. You cannot have the product of two factors that is 0 for one of them not to be 0 at least. But both of them can also be 0. So that's why if you have a product of multiple factors set equals 0, it must be factors. So for example, this one, factor times this one, you can have more, then you can set the condition to find the solution for each of them in case they would be 0. So the zero product principle says that you need to, if the product is 0, at least one of them is 0, so you can test what is it when each of them would be 0. So that means this factor times this one equals 0 means it's either x minus 3 equals 0 or 2x plus 1 equals 0. And then if you pursue this, then you can solve each separately by adding 3 here on both sides. You would get x equals positive 3. By subtracting 1 on both sides for this one, you would have 2x equals negative 1. And then divide by 2, you get x equals negative 1/2. And your solution set for this equation that was already factored is 3 and negative 1/2. So that will be your solution set. So the zero product property, you can use it for any time after you factor your expression. Now, let me try to go over the process of factoring a quadratic expression. Factoring a quadratic expression. You have two different types of quadratic expression. Well, I mean, both of them are quadratic, but there is one where a is equal to 1. So that means you have the 1 instead of a, x squared plus bx plus c. And another one if a is anything but 1. Well, we know it can't be 0. So let's see how to perform the factorization when A equals 1. Well, it's simpler, but you can do the same thing using the same method by grouping. But let's see the easy one. Easy one is that first, the C value, you need to break it into two numbers to factor it into two numbers, number 1 and number 2. You factor it in two numbers, and the sum of these two numbers, number 1 plus number 2, should be equals to B, the coefficient of X. Now, once you have that, you can think about splitting X into two X's. X times X is X squared, and then draw your answer as X plus the first number times X plus the second number. So first, you split the C into two numbers, and then X as X times X, and then draw the answer as two parentheses, and then X plus first number and X plus second number. So that's the easy way. When A is not 1, then you're going to want to multiply A and C to get AC, and then do the same thing with AC, do the same thing with A times C. Whereas you need two numbers, number 1, number 2, such that the sum is B. And now you can separate the BX as number 1x plus number 2x, because number 1 plus number 2 was B. And then now you would have an expression like this one, where you can group and factor by grouping. So we're going to try to practice this in the next example. In this example, factor completely the following trinomial if possible. I should add if possible. Now, the reason I say if possible, if it's not factorable, then later on you won't be able to solve the quadratic equation using this quadratic expression by factoring. So I need to note this too, because if you cannot solve a quadratic equation by factoring, it's not going to mean that this equation is not solvable. It means that you can't solve it by factoring. Then there will be other methods later on that will be proposed for you to be able to solve this equation. Now, first, before we talk about solving quadratic equations, let's do some examples on how to factor a trinomial, a quadratic expression. So this one, A is equal 1. So we can find two numbers that the multiply to give you 27, and when you add them, you get -12. So you can play with the numbers, however, as long as you want, until you get the right numbers. But since this one is negative, the sum B is negative and C is positive, so we definitely want two numbers that have the sign of B. So sign of B. The two numbers, number 1 and number 2, have the sign of B. If B negative and C positive. So the two numbers will be -3 and -9. So I can draw the answer, two pairs of parentheses, split the X as X and X times X, and then the two numbers, -3 and -9. That gives me the factored form of this expression. So this is the easy one. Let's see this one here. This one, A is not 1. But one thing you need to check, if A is not 1, you may see if whether or not A is the GCF, the greatest common factor of the terms. If it is, then you need to factor it out. So let me factor 3 out. So A is not 1, but it is the GCF of the terms. Because it's the GCF, then we can factor it out. So the expression becomes 3 times x squared minus 2x minus 51 divided by 3. That will be 17. So since 17 is prime, you won't be able to find two factors of negative 17 that will add up to negative 2. So because the only factors of negative 17, the only pairs of factors of negative 17 are negative 1 and 17 or 1 and negative 17. And when you add them, it won't be able to give you negative 2. So negative 1 and 17, the sum is 16. And 1 negative 17, the sum is negative 16. So no pairs of factors, no pair of factors of negative 17 that the sum is negative 2. So you cannot factor this. Thus, you have a prime x squared minus 2x minus 17 is prime. When it's prime, that means you cannot factor this trinomial. Now let's see this one. This one is a four-term trinomial. It's a four-term expression, but you see how these two terms, we could combine them to get one term because they are like terms. But I think I can take advantage of having them separate because that's the only way I can have four terms. So with the four terms, I can factor by grouping. Let me factor this by grouping. Group the first and then the second group, and find the GCF of each group. What's the GCF of the first group? 5x squared plus 35x. The GCF is 5x. So when I factor 5x out, divide each term by 5x. So 5x squared divided by 5x is x. 5x squared, 35x divided by 5x is plus 7x, plus 7. Now let's find the GCF of the second group. Negative 6, negative 42. So negative 6 would be the GCF. Divide each term by negative 6. So that be positive x plus 7. X plus 7, we can pull out the x plus 7. And then divide each group by x plus 7. If I divide this group by x plus 7, cancel x plus 7, I'm left with 5x. If I divide this group by x plus 7, cancel the x plus 7, I'm left with negative 6. So this is the factored form of this expression, 5x squared plus 3x minus 6x minus 42 by grouping. Sometimes later on when you're solving your quadratic equation, you might want to use this process as well. Now next, let's factor the expression 2x squared plus 17x, 2x squared plus 15x minus 27. Well, first observation is that a is not 1. So I'm going to want to multiply the a and c. So that's AC equals 2 times negative 27. So AC will be negative 54. Now I need two factors of negative 54. The sum would be 15. Now, because B and B and C, they have different sign. So both of the factors will have different sign as well. That's the only way you can have the negative here. They have to have different sign. Now let's find two factors that of 54. So you may want to play with the numbers as you're looking for those factors. Let me see if 2 and 27, 2 and 27 would not work. The only reason is because um, if you add them, it will be 29. The sum is 29. And if we want one of them to be negative, actually, so if 2 is negative, then it will be 25, still not working, 25. And then if we switch the sign, give this one negative and this one positive, it will be negative 25, still not working because we want it to be positive 15. So the larger number will take the sign of V. So the larger would still be positive. So you don't even have to check whether the bigger number is negative. So we checked, this one didn't work. Negative 2 is 25. Negative 2 times 27, the sum is 25, so it won't work. Now, let's try for 3, for example. 3 and what? 54 divided by 3 would be 18. But the smaller number should be negative. Plus, so then that's going to be 15. Well, this one works. So we have the two factors. Remember, when A is not 1, we need to break the B term as number 1 plus number 2x, number 2x plus number 1x. So basically, I'm going to write the ax squared term. Let me put the plus 18x first. It doesn't matter which one you put first, by the way, but I want to, since 2 and 18, they share a common factor 2, so I put them together, minus 3x, and then plus the last term that is negative, minus 27. So I have 4 terms, then I can do the same thing that I did here to factor this. So I'm going to group this 2, and then group these 2. GCF of the first group is 2x, so factor 2x, and then divide 2x squared by 2x, it's x, plus divide 18x by 2x, that's 9, minus 3 would be the GCF over here, divide negative 3x times negative by negative 3, that's x, divide negative 27 by negative 3, that's 9, plus 9. And then 9, x plus 9, x plus 9 can be pulled from the groups. So that's x plus 9. Then you put the 2x and then minus 3. So that's the factored form when a is not equal to 1. When a is not 1. Now, that you remember how to factor when the coefficient of x squared is 1, when it's not 1, whether it can be the GCF or not. You know how to factor by grouping. And then you know when it's not 1, you can use factoring by grouping. You can multiply A and C and break the middle term down and then factor by grouping. Now you know how to process in solving a quadratic equation by factoring. And here are the steps. Step 1, write your quadratic equation in standard form. That means move all the terms over and then 0 on the other side, and keep them in order so that you have the middle term that has the power 1, the linear term, the quadratic term that is the term with the x squared, the linear term that's the term with exponent 1, and the constant, the term without variable, equals 0, and that makes it the standard form. And then last, you use the 0 product principle that we talked about here, the 0 product principle that we presented here, to finish the solution after factoring the expression. So the next example will be the same exact expressions that we had earlier. I transform them into equations so we can solve. So that is the same expressions. We can just grab the factored form because that would be step 1 and 2. We should factor. And then now we're just going to use the step 3, which is solving using the zero product property or zero product principle. So for the first one is the same expression. I'm just going to copy the factored form and bring it down here. It's already factored, but I'm going to add the equals 0 since this one is not just an expression, it's a factor, it's a equation. So now we can just go straight to the zero principle, product principle to solve this. That's going to be x minus 3 equals 0 or x minus 9 equals 0 plus 3 x equals 3 plus 9 x equals 9. And your solution set is 3, 9. The next one, we remember that we could not factor it here, right? So because we cannot factor, then we cannot solve by factoring. So cannot be solved by factoring. So that's why when we were talking earlier, we said not all equation can be factored, quadratic equations can be solved by factoring. So this one cannot be solved by factoring, but that does not mean it has no solution. We will process in showing you other method that will cover the part when the trinomial is prime. The trinomial x squared minus 2x minus 17 is prime. If it's prime, then you can use other method. Later on, we'll talk about the quadratic formula. We'll talk about the completing the square so we can perform the solution. But for now, it cannot be solved by factoring. Next, we will solve this one. We can just grab the factored form from the previous example here and then use the zero product principle to solve this equation, which means x plus 7 equals 0 or 5x minus 6 equals 0. So subtract 7 here, x equals negative 7, or add 6, 5x equals 6, divide by 5, x equals 6/5, and the solution set is negative 7, 6/5. Okay, and then lastly, this is the same expression. We can grab the factored form. You remember how we factored it. We'll just want the factored form here because that's one of the steps you're always going to use whenever you're solving by factoring. Equals 0. We forgot to put the equals 0 here. We don't want to forget this because this means that you're solving an equation. And then zero product property here. 2x minus 3 equals 0. We would subtract 9 on both sides. X equals negative 9. We would add 3 on both sides here. 2x equals 3 divided by 2. X equals 3/2. And your solution set is negative 9 and 3/2. So that's how you solve quadratic equations by factoring. Now, let's see how to solve quadratic equation by the square root property. Now, let's see the square root property. If I have u squared equals a, that's a square root property, this equation admits two solutions, not just one. Not just one. The first one is u equals square root of a, or the second one is u equals minus square root of a, which also can be written as u equals plus or minus square root of a. Now, I say u because it can be a whole expression squared equals a constant. You can still apply the square root property. So I'm looking at this equation. The only term that has the variable is the term that has x squared. So I can just isolate the x squared to get the u equals constant. Let's go ahead and isolate the x squared. So basically what I'm saying here is if the quadratic equation has only one term, the x squared term that has variable, the other terms, there's no linear term, you can always solve this equation by the square root property by isolating the square. So let me add 8 on both sides to isolate the x squared term. 2x squared equals 8. Then we divide by 2. X squared equals 4. Now we can apply the square root property that says if I have something squared equals a constant, the thing squared without the square can be equal to solution, square root of the constant, or x would be negative square root of the constant. In this case, constant is 4. So x is 2 or x is negative 2. Your solution set to negative 2. Please make sure you don't forget the square root property that says if you have variable squared equals constant, the solution will be two of them. It's plus or minus the square root of the constant. So we have that can be seen as u, right? It's an expression raised to the second power minus 9 equals 0. So we can just subtract, add the 9 on both sides, isolate the part that has the square, and then you have 3x minus 2 squared equals 9. Use the square root property that is 3x minus 2 equals square root of 9, or 3x minus 2 equals negative square root of 9. So that is 3x minus 2 equals 3. If we add 2 on both sides, 3x equals 6. We'll divide by 3. And then get x equals 2. We get the first answer. Now next, that's 3x minus 2 equals negative 3, right? Then if we add 2 on both sides, 3x equals negative 1, divide by 3, x equals negative 1/3. So your solution set is 2 and negative 1/3. Can apply the same thing here too. Add 98. 2 times 3 minus x squared equals 98. Divide by 2. 3 minus x squared equals 98. That's 49. And then two equations can be created. 3 minus x squared equals square root of 49, or 3 minus x squared equals negative square root of 49. Negative square root of 49. Okay, and now let's solve the first one. There's no square, actually. There's no square here. There's no square for that, okay? Because you solve the square by taking the square root. Now we can just subtract 3 on both sides. So negative x equals, this is 7. 7 minus 3 is 4. And multiply by negative 1, x equals negative 4. We can subtract 3 here as well. This is negative 7. So negative x equals negative 10, right? And divide by negative 1, x equals 10. Your solution set is negative 4 and 10. The last one is pretty much the same thing. We're gonna do it as well. So we can add 15 on both sides of the equation. 15 on both sides. And then that is 3 times 2 minus 4x squared equals 15. We'll divide by 3. So we get 2 minus 4x squared equals 5. And then apply the square root property. That is 2 minus 4x, 2 minus 4x equals the square root of 5, or 2 minus 4x equals negative square root of 5, right? And then now we can subtract 2 on both sides. Negative 2 on both sides. Negative 4x equals negative 2 plus square root of 5, or subtract 2 on both sides of the other equations as well. Negative 4x equals negative 2 minus square root of 5. So with that, we can divide by, I want to divide both sides by negative 1s to switch the sign of the 4x. So that's 4x equals 2 minus square root of 5, or 4x equals 2 plus square root of 5. And that divide by 4, x equals 2 minus square root of 5 over 4. We divide by 4 with this one as well, or x equals 2 plus square root of 5 over 4. In the solution set, 2 minus square root of 5 over 4, 2 plus square root of 5 over 4. So that is using the square root property and the zero product property to solve quadratic equations. So over here we have a few more practice problem that is more different. It's because most of the problems that we solved earlier, they were in standard form, but these ones, they are not, they are in different forms, but it's going to be your turn to put them in standard form and apply all the rules that we talked about earlier. So go ahead, we're going to do this. You might want to write those problems on your paper because they may be different, but it's just the actual question that you're going to have to write, but the answers are different because I printed the notes after I realized those problems, they were more to solve using different method than the factoring method. So please make sure you write the problems. You scratch out the problem that is on your paper and copy this one instead. these ones, the next ones, practice ones. Okay, so this, we want to move all the terms on one side so that we can get the standard form of the equation. So that means we're going to need to subtract 21 on both sides and add 4x on both sides to get x squared minus or plus 4x minus 21 equals 0. Now, because a coefficient of x squared is 1, I can draw my factored form while I'm looking for two factors of negative 21 that the sum is 4. Those are going to be 7 and negative 3. So then x plus 7, x minus 3 are the factors equal 0. So that said, I can solve x plus 7 equals 0 or x minus 3 equals 0. Subtract 7 on both sides, x equals negative 7. Add 3 on both sides, x equals positive 3. And my solution set, negative 7 and 3. Next example here, pretty much the same thing. We want to find the standard form and then solve the equation using by factoring. Solve the equation by factoring. So we're gonna add 15 on both sides to get 2x squared plus 11x plus 15 equals 0. Since a coefficient of x squared is not 1, so we're gonna want to multiply the coefficient of x squared and the constant to get AC equals 30. Now, two factors of 30 that the sum is 11 are 6 and 5. So I'm going to break down the middle term 11x as 6x plus 5x. So we have the equation in 4 terms now, 2x squared plus 6x plus 5x plus 15 equals 0. Factor by grouping, first group, second group. The GCF for the first group is 2x. So that's going to be x plus, when you factor 2x out, you would get 2x outside. And what multiplies 2x to get 2x squared is x. What multiplies 2x to get 6x is 3. Plus GCF of the second group would be 5. So that'd be x plus 3 as well, equals 0. Now, x plus 3 can be factored out to get x plus 3 times the two factors of x plus 3 that we had in the previous example, previous expression. So 2x, or previous step, plus 5 equals 0. Now we can use the 0 product principle, that is x plus 3 equals 0 or 2x plus 5 equals 0. Solve them separately, negative 3 on both sides, x equals negative 3, negative 5 on both sides, 2x equals negative 5, and divide both sides by 2, x equals negative 5 over 2. Solution set is negative 3 and negative 5 over 2. We got more examples. In this one, you must factor the GCF because the C term, missing the C term, missing the constant. So when it's missing the constant, you should factor the GCF and then apply the zero product property. So let me factor negative 5x out. So that would be 3x minus 2, right? Equals 0. So that's one factor, and that's another one. We can use the zero product property, negative 5x equals 0, or 3x minus 2 equals 0. By the way, factors are not only when you have parentheses. That's why this one is also a factor, and you can still use the zero factor principle, the zero product principle, to solve this equation. Can divide by -5. So that's x equals 0, because 0 divided by -5 is still 0. Over here, we can add 2 on both sides. 3x is 2. Divide by 3, we get x equals 2/3. Solution set is not just 2/3, it's 0 or 2/3. Couple more examples. Solve the quadratic equation by using the square root property. So square root property here, since it's already isolated, we can just use the square root property. X minus 6 equals square root of 5, or x minus 6 equals negative square root of 5. Add 6 on both sides. Get x equals 6 plus square root of 5. That's not 11. That's not square root of 11. That's just 6 plus square root of 5, because they're not like term. You cannot add them. Combine them, you cannot. Or x equals 6 minus square root of 5, which makes the solution set 6 plus square root of 5, 6 minus square root of 5. Two last examples here. Remember, I said they may be different from your problems, but the same type of problem. The numbers are different, and the ones on your paper, they can only be solved using different methods. So I changed the problems. So here we have 2x squared. We want to move this over, change the sign of 9x. Minus 9x minus 5 equals 0. We got the a coefficient of x squared, that's not 1. So we're going to want to multiply a and c. That's ac equals -10. Two factors of -10, -10 that the sum is -9, are -10 and +1. And we can write the left side of the equation using 4 terms, breaking the -9x as -10x plus 1. So that's 2x squared minus 10x plus 1x, just plus x, minus 5 equals 0. Let's factor that's my first group, that's my second group. GCF of the first group is 2x, so that's x minus 5. GCF of the next group is just 1, so that's x minus 5. 1 times x minus 5 equals 0. So that's x minus 5 times 2x plus 1 equals 0. Now, the expression is factored, then we can use the zero product property. X minus 5 equals 0, or 2x plus 1 equals 0. Add 5 to get x equals 5 from the first, and subtract 1 to get 2x equals -1, and divide by 2 to get x equals -1/2. So your solution set 5, -1/2. And finally, we have this example here, where we have the a that's not 0, that's not 1. A is not 1. We would multiply a and c. AC equals 7 times 12. That is 84. Two factors of 84 that add to -20 will be -14 and -6. -14 and -6. So we would we write negative 20p as negative 14p minus 6p, and then 7p squared minus 14p minus 6p plus 12 equals 0. The first group and the second group. GCF is 7p, so that's p minus 2, and then negative 6, so p minus 2 equals 0. Factor the p minus 2 out, so 7p minus 6 equals 0. And then use the zero product property, so that's p minus 7, p minus 2 equals 0. Add 2 on both sides, p equals 2, or 7p minus 6 equals 0, which gives, if we add 6 on both sides, 7p equals 6, and I divide by 7 to get p equals 6/7. So solution set is 2 and 6/7.